Hey, physicists. So, in the last example, in example six, when we were talking about Miss Piggy and her picture that was hanging on the wall, I introduced a new force to you, and that was the force of tension. So, I just want to make sure that we've got our understanding of tension figured out, and we'll add it to the inventory so that you've got it ready to go. So, tension is a pretty straightforward force. Sometimes people get a little bit anxious about it and a little unsure about it, but really all that it is it's a force that goes along a string or a rope or something like that. So I've got my two little stick people here, and they are having it looks like a tug of war. And as they pull on that rope, okay, they are making a tension in that rope. And so my person A here is being pulled, it appears, by person B, but person B is not touching person A. Do you see that? Person A is being pulled by the rope. So there's a force in this direction, a force of the rope on person A. Person B is feeling a force as well. Again, not from person A, but from the rope, force of the rope on person B. Okay. Now, the cool thing about the tension force is that the tension force is really just a transfer of force. So the rope on A and the rope on B, those two forces are exactly the same. Person B can't pull harder than person A is pulling, and vice versa. So that that tension force is really just stretching out or transferring the force from one place to another. That is really all it is. So we're going to now add that to our force inventory so you can kind of have it recorded there with everything else. So right under friction, we're going to add another one. This is going to be F sub T, the tension force. And then the next question is what object is pushing or pulling? So what is involved in tension force? The big thing that we know if we ever see a rope or a string or a thread or anything like that, we're talking about tension. So we'll just say, we'll write all those down: a rope or a string or a thread, a cord, you get the idea. Any of those kind of long things like that is going to, can potentially cause a tension force. In terms of the direction of the tension force, you can imagine that a string can be pulled in lots of different directions, but the thing that is important for us to remember is that the direction of the force itself will always be along the rope or the string, okay? So the direction of the force, as I just said, will always be along the string, away from the object. Okay, so in terms of the diagram, it's not always going to be up or down or right or left or anything like that. But the thing to remember, so if I draw my object, generally when you draw a free body diagram, you're not going to draw the rope, but in this case I will, just so that we can kind of see what would be happening. So if the rope was in this direction like this, and somebody's pulling along there, then the force would be going along that rope. So it'd be like this. And we're going to write force of rope on object. Okay. Is a tension force able to cause acceleration? Well, sure it is. You can imagine like a leash if you're like pulling something, or if you have a cord that is allowing you to pull, or like to pull a box or something like that. Yep, tension is for sure able to cause an acceleration.